Hey everyone, welcome back. We are finally starting a new topic, and this topic's name is going to be polynomial functions. A lot like quadratics, just with larger exponents, essentially. So here's the form for it. Mostly probably looking pretty familiar. With quadratics, we had ax squared plus bx plus c. But now, our exponent can be larger than 2. For example, 3. And I forgot to put a square there on this one. So you start off with the largest exponent. Each variable can have a coefficient. Sometimes it's just 1. Um, and you write this going down or in decreasing order for the exponent. So you go from 3 to 2 to 1, and then your constant. And that's what k is down here. So not too different from quadratic functions, but they can certainly start to look pretty cool and model some awesome real world situations. Hey, so there's two things that we're going to try to accomplish today. We just want to figure out what's the degree. What is the degree of the function? So degree refers to the largest exponent, the value of the largest exponent. That is the degree of the function. And the other thing that we're going to try to do is describe the end behavior. The end behavior. So end behavior with a polynomial function, that just is referring to what happens with these arrows. What happens at the very, very end of this function? Where is it going? Is it going to positive infinity or negative infinity? And that's really it. Hey, so for this first example that I graphed here, we have a cubic function because the degree is 3. Awesome. So hey, let's find the degree and the end behavior of this function. So the degree is 3. The largest exponent up here is 3, so the degree of this function is 3. For what it's worth, it's called cubic. All right. And now the end behavior. Let's describe the end behavior. So this is not difficult, but it's written in a way that might be kind of confusing at first. So the end behavior, a lot to it. So the end behavior as x, so we're looking at this value, as x approaches positive infinity, where's our function going? F of x approaches, so just reading the function, going from left to right, what happens at the end here? Where's our function heading at the very end? It's pointing upward. That means it's going to positive infinity. So as x increases or approaches infinity, f of x also approaches positive infinity. And that's really it. But we also go the other direction. So hey, as x approaches the left side of our graph, going that way, as x approaches negative infinity, f of x approaches, our actual function approaches, as we go to the left, you see it's going down this way. So f of x approaches negative infinity in that direction. And hey, that's really how you answer that question, the end behavior. As x goes to positive infinity, where's your function going? As x approaches negative infinity, where is your function going? And that's it. Okay, so I got one more example here. Same thing, let's find the degree. What is the degree of this function? So this is a 4th degree polynomial. It's a 4th degree polynomial because the largest exponent right there is a 4. Hey, and this is called a quartic function. Okay. Now we'll do the end behavior. End behavior. So the end behavior just takes a lot to write it out. As x, really simple concept, I think. It just looks kind of scary. So as x approaches positive infinity, so that's just a way of saying we're going to the right in the left-right axis. As we approach this direction and we're using our function, where is it going? Just continually goes up. It's never going to stop. As x approaches positive infinity, it looks like our function is going to approach positive infinity as well. Okay, not so bad, huh? And then as x approaches the other direction, which we write out as x approaches negative infinity. As we move to the left on our function, where does it end up? Hey, this one too, it's also going positive. It's going in this direction. As our x values approach these negative infinity values, as x approaches this direction, f of x approaches positive infinity again. F of x approaches positive infinity. Okay, that's it. That's how you describe degree and also the end behavior. Thanks for watching. See y'all in class. Bye-bye.